Hey everyone, and welcome. So we all know the AI revolution is happening, right? It's being built inside these absolutely massive, power-hungry data centers. But what's the actual price tag? What does it really cost to build our AI future? Well, we're about to dig into a groundbreaking report that gives us a pretty serious reality check.
So let's just throw a number out there, a huge one, $60 billion. This is a figure that's been making the rounds, and it comes straight from the biggest name in the game, NVIDIA. They've suggested that a single 1 gigawatt AI data center could cost as much as $60 billion. That is just a staggering amount of money.
But here's the question we have to ask. Is that the full story? Is $60 billion the actual on-the-ground cost to build one of these computational powerhouses right now? Or is there another number we should be paying way more attention to?
Okay, so where does a number like 60 billion even come from? Well, you have to understand we are in a full-blown AI arms race. I mean, the tech giants are just pouring hundreds of billions of dollars into building the infrastructure for the next generation of AI. The spending is absolutely massive, so it's really crucial to understand where that money is actually going.
And this is where it gets interesting. A bombshell industry report from the analysts at Bernstein kind of throws a wrench in those numbers. They've done a super deep dive, and their analysis gives us a vital reality check. And, you guessed it, a significantly lower number.
And here it is, side by side. This really gets to the heart of the debate. On one side, you've got NVIDIA's $50 to $60 billion estimate, which they call forward-looking, so it's probably pricing in future, more expensive technology. But then you have Bernstein's $35 billion figure, and that's what they're calling the near-term cost, what it actually costs to build one of these things today. That's a potential $25 billion gap between perception and reality. That is huge.
Okay, so let's take that $35 billion number and run with it. If that's our baseline, where does all that cash actually go? It's time to roll up our sleeves, dissect the anatomy of a modern AI data center, and really see the cost breakdown for ourselves. You know, at the highest level, the split is surprisingly simple. You might think it's super complicated, but it really boils down to two big buckets. As you can see here, over half the cost, a solid 57%, goes directly into the compute hardware, the brains of the whole operation. The other 43%, that's for all the physical infrastructure that keeps those brains from, melting. Now let's zoom in a little closer on that hardware cost. I mean, these numbers are just really revealing. The GPUs, the absolute workhorses of AI, they account for a massive 39% of the entire data center cost. Just look at that compared to everything else. Networking is only 13%, and the good old CPUs, a tiny 3%. It really is all about the GPUs.
So what about storing all the data? I mean, surely that costs a fortune, right? Well, not exactly. This quote from the report is just so telling. Storage has become scrap in the AI era. It's incredible. Its cost is basically negligible, just 1 to 1.5% of the total. And why is that? It's because these places aren't digital libraries for hoarding data. They are pure, raw computation factories.
All right, now for that other side of the pie chart, the physical infrastructure. And this stuff is just as critical. We're talking massive power generation systems, we're talking advanced cooling to handle all that insane heat, and of course the entire upstream supply chain that makes the components in the first place. This is the nuts and bolts of the operation.
Okay, so we know where the money is spent. We've broken it all down. But I think the more interesting question is, who gets it? Who are the biggest financial winners in this insane AI infrastructure boom? Let's follow the money.
I want you to just look at this number for a second. 29%. Just think about that. What could possibly account for nearly a third of the entire cost of a $35 billion project all by itself?
The answer is, it's pretty astonishing. That 29%, that's NVIDIA's gross margin. And to put that in simple terms, that's not just the revenue, that's the profit they make on their sales. For every single dollar spent on one of these data centers, 29 cents goes directly into NVIDIA's pocket. It just shows you how central and how unbelievably profitable their position is in this whole ecosystem.
Let's actually translate that 29% into real dollars, because it's wild. For every single 1 gigawatt AI data center that gets built at this $35 billion price tag, a staggering $10 billion goes directly to NVIDIA as pure profit. Just think about that. $10 billion in profit from a single project.
But hey, NVIDIA isn't the only one winning here. This table really shows the whole ecosystem.
And while GPUs get all the headlines, I want you to look at the power and M&E category. That's mechanical and electrical. Companies like Siemens and GE Vernova are pulling in nearly as much of the total cost as NVIDIA is in revenue. The money is flowing not just to the chip designers, but to these industrial giants who build the physical world around them.
In that massive spending on power infrastructure, well, that brings us to what the report says is the next major challenge. Because as this AI arms race keeps getting more intense, the bottleneck is actually shifting away from the chips themselves and towards something way more fundamental.
So here's how it plays out. As the computing power in each server rack just skyrockets, so does its thirst for electricity. This forces the whole industry to shift to new, high-voltage designs. And the impact of that is huge. The cost of these crucial power components is projected to jump by 7 to 8 times. All of a sudden, just the ability to deliver reliable power becomes the new choke point for the entire AI industry.
And this power bottleneck really highlights the difference between the one-time build cost, that's your CapEx, and the ongoing running costs, or OpEx. It takes $35 billion to build, sure, but then it costs over $1 billion every single year just for the electricity bill. And what about staffing? This is wild. The report estimates that a massive 20-gigawatt complex might only need 10 people to run it. The real ongoing cost isn't people, it's power.
So, after breaking down all the costs, following the money, and looking at the big problems on the horizon, what's the ultimate takeaway here? Where is the real gold mine in the age of AI?
This final quote from the Bernstein report really says it all. Whoever controls power and high-voltage components holds the AI era's gold mine. I mean, they basically put it in neon lights. While chips are obviously critical today, the report is suggesting that the future value is going to shift to whoever can solve this massive power problem. That's where the real money might be made down the road.
And that just leaves us with one final thought to chew on. As this whole AI arms race just keeps accelerating, who really holds the ultimate power? Is it the companies that design the silicone, or is it the ones who can actually provide the electricity to bring it all to life? Something to think about. Thanks for watching.